Welcome everyone to Math Simplified by HM. I am thrilled to guide you through the formal proof of the parallelogram law today. We are going to see the perfect balance between a parallelogram's diagonals and its sides. Please like, share and subscribe with the bell icon turned on so you never miss a lesson. Grab a notebook, hit pause whenever you need, and let's get started. Properties of parallelograms: sum of squares of diagonals versus sides. A complete proof walkthrough, step by step derivation. We read the theorem statement very carefully. Prove that the sum of the squares of the diagonals of a parallelogram is equal to the sum of the squares of its sides. Now, setting the stage, what is given and what we have to prove. Given, let triangle PQRS be a parallelogram. Construction: draw segment PR and segment QS intersecting at point P. We have to prove that PQ square plus PS square plus QR square plus SR square is equal to PR square plus QS square. The mathematical toolkit: two foundational geometric rules are required for this proof. Parallelogram diagonals. Rule: diagonals of a parallelogram bisect each other. The result is that PT is equal to TR and QT is equal to TS. Apollonius Theorem. Rule relates the sides of any triangle to its median. Side 1 square plus side 2 square is equal to 2 times median square plus 2 times half base square. In this triangle, if A is the median, then AB square plus AC square is equal to 2 times AM square plus 2 times BM square. Isolating triangle PQS. Let us isolate the bottom triangle PQS. Because diagonals bisect each other, segment PT is the median to base QS. Applying Apollonius Theorem to triangle PQS, we get equation 1: PQ square plus PS square is equal to 2 times PT square plus 2 times QT square. Similarly, consider the adjacent top triangle RQS. Again, because the diagonals bisect, segment RT is the median to base QS. Applying Apollonius Theorem to triangle RQS, we get equation 2: QR square plus SR square is equal to 2 times RT square plus 2 times QT square. Now, next step is the algebraic synthesis. Add equation 1 and equation 2 to combine all four sides. PQ square plus PS square plus QR square plus SR square is equal to 2 times PT square plus 2 times QT square plus 2 times RT square plus 2 times QT square. Group the matching terms logically. 2 times PT square plus RT square plus 4 QT square. Recall, diagonals bisect each other, so RT is equal to PT. Replace RT with PT. We get 2 times in bracket PT square plus PT square bracket complete plus 4 QT square. This gives us 4 PT square plus 4 QT square. Now rebuilding the diagonals. From step 3, the sum of the squares of the sides is exactly equal to 4pt square plus 4qt square. Rewrite these terms mathematically as perfect squares. That means 2 times pt bracket square plus 2 times qt bracket square. Now look closely at the diagram. What is 2pt? 2pt is the full diagonal PR. Similarly, 2qt is the full diagonal QS. So we reach to the final conclusion. Substituting the full diagonals back into our equation yields our proof. PQ square plus PS square plus QR square plus SR square is equal to PR square plus QS square. Therefore, the sum of the squares of the sides of a parallelogram is equal to the sum of the squares of its diagonals. Look at this equation. We know that PQ is congruent to SR and PS is congruent to QR. So we can write this like also 2 times PQ square plus 2 times QR square is equal to PR square plus QS square. Synthesis matrix, the quadrilateral family. How does this universal theorem adapt to specific types of parallelograms? We know that rhombus is a parallelogram. All four sides are equals and diagonals have different length but they bisect each other. Therefore, we get 4a square is equal to d1 square plus d2 square. Rectangle, diagonals are equal. So we get 2 times length square plus 2 times width square is equal to 2 times diagonal squares. Simplifying, we get length square plus width square is equal to diagonal square. And this yields the Pythagoras theorem here. Square. All sides are equal, diagonals are equal. So 4a square is equal to 2d square implies 2a square is equal to d square. Thus, we have proved the parallelogram law and how it transforms specific types of parallelograms. Thank you for your attention. Please like, share this video to all your well-wishers, colleagues, friends. Subscribe the channel and click the bell icon to stay updated. Enjoy the great time ahead.